Hi guys, just a quick lesson on geometric sequences. So with geometric sequences, it's going to be given as a list again with commas, and when you study the geometric sequence, you should realize, or you should notice, that it's no longer a common difference between them, because then they would be arithmetic, but what you're looking to see is a common ratio. Okay, so the common ratio is going to be determined by multiplying or dividing the previous term from the term that you're finding. Okay, so from 3 to 6, from 6 to 12, 12 to 24, I can see that they have a common ratio, and the common ratio is that they're being doubled, so each one of those is being times by 2. Okay, so I can see that that has a geometric sequence. So again, you're looking for multiplication or division for geometric sequences to work out the common ratio. These are the important formulas. So the recursive formula, again, recursive formula always has two parts, so you can give the equation, which is here, so an is equal to an minus 1 times r, but remember that you have to give the first term, okay? So always remember to state a1, or you could call it t1, or you could call it just a, if you're given a recursive equation, formula, or definition. Okay, so that's really, really important. Another way that you might see this recursive definition is you could see it as sorry, that's a bit fat. An plus 1 is equal to an, so the previous term, times r. Okay, so an plus 1 is the term that you're trying to find, as opposed to an, it's an plus 1, so the previous term of an plus 1 is just going to be an. Okay, and we also can come up with another rule from that formula, and it's to work out the ratio. So to work out the ratio, I bring my an across and I divide, so I would end up with, or if I'm using this one, I bring my an minus 1 across and divide, so I end up with an divided by an minus 1. Okay, so again, your term divided by the previous term, okay, to work out the ratio. And the general form then is when you're not using the recursive, so you're not dependent on the previous term, so you're going to use this formula here. So an is equal to the first term times the ratio to the power of n minus 1. Okay, so an is the nth term in the sequence, a1 is the first term, or a, or t1, and this could also be tn, and n is the number of the term, and r is the common ratio. Okay, so if you're given any three of these, you should be able to find the fourth. So if you know any three of these, you should be able to find the fourth. So if you're asked to find the nth term of a sequence, then you can use this formula here. If you're asked to find r, you can use this formula here. If you're asked to find n, if you're asked to find the first term. Okay. Which of the following sequences are geometric? So again, for geometric, you're looking for a common ratio, so multiplying or dividing, and asks you to identify the common ratio as well. So looking at the first one, negative 3 to negative 1 to 1 to 3 to 5 to 7. I don't have a common ratio there, I do have a common difference, so no, that is not going to be a geometric, it's actually arithmetic. 1 to negative 6, I'm timesing it by negative 6. Negative 6 to 36, I'm timesing it by negative 6 again. 36 to negative 216, I'm timesing it by negative 6. So yes, that is geometric, and my ratio is a geometric progression, and my ratio is equal to negative 6. Okay. For this one here, I'm going down 4, then I'm going down 6, then I'm going down 8, so nothing with that one. It's not even arithmetic, that one. So no. And for this one here now, we're going to show a little bit of working for this one. Again, because it's fraction form, it's not as easy to see the common ratio if there is one. I'm trying to show whether it's geometric or not. So I'm going to work out my ratio. So my ratio is going to be my negative 3 over 2 divided by my 3. Dividing by 3 is just the same as negative 3 over 2 times, flip it so it becomes 1 over 3, and I end up with 3 over 6, sorry, negative 3 over 6, which is equal to negative a half. Okay, now that's only finding one ratio. I have to show that it's a common ratio, so I need to do the same to another two terms. So if I do it using 3/4 and divide it by the previous term was negative 3 over 2. And again, to divide fractions, I have to keep change flip, so keep the 3/4. Keep the 3/4, times it by 2 over -3. -3, and I get 6 over -12, which is of course -1/2, so I can see that I've got a common ratio. Sorry, my pen's a bit weird there. So my common ratio is r is equal to -1/2, so yes, that is a GP. Okay. This last one, again, looking at that, I am straight away noticing that I'm going up by 6, so it's +6. So again, that's not a geometric, it's an AP, or an arithmetic progression. Okay, so that's how you're working it out. We're using this formula here, which we had already seen on the previous page when we rearranged our recursive formula. That gave us this formula here, so I was just bringing that over. That's how we work out the ratio using this formula, where your n actually has to be greater than or equal to 2, and that's really, really important, okay? Because 2 take away 1 is 1. If you had 1 take away 1, you'd have 0, and then you wouldn't be able to apply it, okay? Next one, so these are all the different examples that you could be given. So this one here, 11, 33, 99, 297. So again, check what kind of sequence it is. It is a geometric sequence. We can see that straight away. It's a GP, or geometric progression. My A1 is 11. My ratio is obviously going to be 33 divided by 11, which is equal to 3. And you might want to check as well that that works for a different set of terms. So 99 divided by 33 is equal to 3, so yes, it does. My r is equal to my 3. I won't write that there because it's going to go over into my working out part. And my n, of course, is 12 because I'm trying to find the 12th term. So using my formula from before, I'm going to use an is equal to a1 times my rn minus 1. So this is my formula. Do I have everything that I need? I have my a1, I have my r, and I have my n. I've already identified them over here. Okay, so I'm trying to find a12 is equal to a1 is 11 times my r, which is 3, to the power of 12 take 1, which is obviously going to be 11. And when I put that into my calculator, I end up with 1,948,617. Okay, so my 12th term in that geometric progression, obviously it's getting really, really big really quickly because it's grown by a ratio of 3, and this is what I end up with. Okay. Next question, so getting a little bit harder as these questions go along. 5x and 45 is the geometric sequence, so find the value of x. So again, if it's a geometric sequence, these have to have a common ratio. So what I can do is I can write down the ratio is equal to, it's the second term divided by the first term, or the third term divided by the second term, so it's always the term divided by its previous term, so I can say that it's x over 5. I could also use the second and third terms by saying 45 divided by x, okay? Now if both of them are equal to x, because I'm told it's a geometric sequence, so I know it has a common ratio, so therefore these two r's have to be equal to each other, so I can rewrite that as x over 5 is equal to 45 over x, and then I can cross multiply. Okay, and when I cross multiply, I end up with x squared is equal to 5 times 45 is 225, so the x is equal to the square root of that, which is 15. Okay, so my x in my sequence was 15, and then just go back and check that that makes sense. And my ratio is 3, so 5 times 3 is 15, 15 times 3 is 45, so I've checked. Okay, the next example, I'm trying to prove that this is a geometric sequence. I'm not told it's a geometric sequence, I'm trying to show that it is. Okay, so in order to show that it is, what does it have to have? It has to have a common ratio. So again, I'm going to look at finding my ratio. So it's the term 2 divided by term 1, or term 3 divided by term 2. So my ratio is equal to 1/6 divided by 1/4, which then becomes, keep change flip again for your fractions, times 4 over 1, which is equal to 4 over 6, which is equal to 2 over 3. If I try the next one, so term 3 divided by term 2, so again it's your term divided by your previous term, so it's 1 over 18 divided by 1/6, which is equal to, keep change flip, so 1 over 18 times 6 over 1, and I get 1 times 6 and 1 times 18 is 6 over 18, which is equal to 1/3. Okay, so straight away I notice now that these two numbers are totally different, so their ratio is not common, so therefore it's not a GP, or a geometric sequence. Okay, and that's what you would do to show that. Okay, this example here, does the following belong to the geometric progression 1, negative 2, 4, and negative 8? So again, I'm going to have to identify a few things. So I can identify that my A1, or my T1, is equal to 1. Or I could just call it A. So T1, A, they're all the same thing. So T1 is equal to 1. My ratio is going to be equal to my negative 2 divided by 1, or I could have taken my 4 divided by negative 2, and I know it's negative 2 is my answer. Again, I was told it was a geometric progression, so I don't need to show that these have a common ratio. I know they have a common ratio, so it's okay to just take one term and divide it by the term in front of it. Okay, so negative 2 divided by negative 1. And I'm also going to, I'm trying to work out what term number this is, if it is a term number. So if it is a term number, it's going to be Tn is equal to negative 32,768, okay, and I'm trying to find which term number it is, if it is a term number, okay. So I'm going to use my general equation. So Tn is equal to T1, or An is equal to A1 times my r to the power of n negative 1. Plug in what I know. Negative 32,768 is equal to 1 times my r is negative 2, all to the power of n negative 1. Now n negative 1 is the one that I'm trying to find, so again it's a power that we're trying to find, so at this point you could use your CAS and you're going to solve for n. You should all know how to do that at this point, and n then is equal to 16, so therefore negative 32,768 is the 16th term. Okay, so again, as I said, these examples get progressively harder. So this was a CAS question. You were trying to find an unknown variable that was an indice. So what you could have worked out is that negative 32,768, this number here, is actually the same as 2 to the power of 15. And then that would have given you this part here. So if you'd taken away 1, you had to add it back on, and you got 16. Okay, so it is possible to do that manually, but it's more likely to come up on a CAS calculator paper. Okay, the next question, a little bit harder again, but this is our last one. So the second and sixth term of a geometric sequence are the following: 28 and 448 respectively. What is the 10th term of this sequence? So again, what can I identify from the information given? I can identify that T2 is equal to 28, and I can identify that T6 is equal to 448. Okay, now from my general form of a geometric sequence, I know that it's the first term, so A1 or T1, sorry, just call that T1, or I'll call it A actually this time, times the ratio to the power of n minus 1. My n in this situation is 2, so I can say 2 minus 1 is 1, so it's r to the power of 1. Okay, I hope everybody's okay with that. So again, for my general term, T6 is going to be the first term, which is A times the ratio to the power of n minus 1, and my n minus 1 is 6 minus 1, which of course becomes 5 minus 1. Sorry, just 5. 6 minus 1 is 5. Okay, so these are my two equations that I've identified. So that's my first equation, that's my second equation, and now I'm going to go on to solve it. So because these are being multiplied together, normally we're used to simultaneous equations with pluses and minuses. Because these are being multiplied together, I can do 2 divided by 1 and see what I get. Okay, so if I do 448 divided by 28, I end up with 16. If I do A divided by A, they actually cancel out, so they leave me with 1. And if I do R5 divided by R1, so R5 divided by R1, we take away the powers, so I end up with R to the 4. So again, 16 is going to be equal to R to the 4. Okay, now 16 can be written as plus or minus 2 to the power of 4. It's an even power, And the even power will make this answer positive no matter whether it's plus or minus to begin with, okay? So that's equal to r to the power of 4, so my r is obviously equal to plus or minus 2. Okay, again, now think about what you need to find. We're trying to find the 10th term. In order to find the 10th term, I'm going to have to use the formula a times r to the power of 9. Okay, so it's not enough for me just to have my r. Okay, I also need my a. Okay, and my a is my first term. So now using this, I'm going to find my a, which is my first term. So my first term is equal to my second term divided by my ratio, which is now plus or minus 2. Okay, and my second term we knew was 28, so it's 28 divided by plus or minus 2, which is equal to plus or minus 14. Okay, and that obviously, those signs correspond with the signs that you use. So if you're dividing by a positive 2, you'll get positive 14 as your answer. If you're dividing by negative 2, you'll get negative 14 as your answer. And that's really important. So now to find my T10, I'm going to plug in those numbers. So my T10 is equal to my A. So if I take A as 14, positive 14 to begin with, I have to take the ratio of positive 2 to begin with. And I get 7168. And if I take T10 with a negative 14, that would mean my ratio was negative 2. So negative 14 times negative 2 all to the power of 9. You might want brackets when you're putting this into your calculator. And you end up with 7168. So actually it doesn't matter which, whether you take the positives or the negatives, you will still just get an answer of 7168, 7168 for your T10, your 10th term. Okay, and yeah, that's it. So if we can do all those examples, we should be able to do all the questions. Okay. Perfect. Okay, well done. Thanks, guys.